of you. Today we are going to talk about fact analysis, both exploratory fact analysis, confirmatory fact analysis, and also we'll discuss about how to do this in Jamovi. Now, yesterday during my class, I discussed about the theoretical aspect of running fact analysis. Now, today what we try to do is we try to get a data set and then we run a fact analysis. So I hope this will help you learn more about uh, fact analysis, not just how to run it, but also how user-friendly it is when you run it through Jamovi. Because I always think compared to SPSS, Jamovi is much more easier to be used. So that is exactly what we will be doing today. So let me share my screen here. So I already have Jamovi here opened up. Now what I'm going to do is I'm going to open up my data set. So I have a data set that I have used previously. This is generalized self-efficacy scale. So this is the Jamovi interface. So I'm going to open my data now. Okay, I'm going to click browse here. And then I'm going to select my data. Okay, give me a second. I'm going to just locate my data set. Okay, this is actually one of my students' data set. She did a study on culturally adapting teachers' sense of efficacy scale. Now, okay, here you go. So she has done a study about culturally adapting and statistically validating teachers' sense of efficacy scale. So while she was doing it, I also asked her to collect data for my general self-efficacy scale as well. One is to show that we wanted to show criterion validity for both the scales. So we decided by showing a correlation between them, we can show some criterion or predictive validity as well. Okay, now this is the data set. Here you would see participant information, the unique codes, age, gender, and the questions. We have 10 questions here, and then some other variables the student has collected as well. But now all of them are given in, it says that they are all nominal, so I'm going to just change them first. So double click on age. I'm going to change the measuring type. This is going to be a continuous variable, gender nominal, okay. And these questions, I'm going to make them ordinal. They are in fact ordinal. This is a question I have been having for the longest time because they are categorical, but then from one category to another, there's a bit of an increment, right? So because of that, I think I'm going to consider them as ordinal. Okay. These are all questions in the generalized self-efficacy scale. The scale is a 10-item scale. It is a unidimensional scale, which means I'm expecting to see only one factor when I run fact analysis. So that is exactly what we are going to check today. But before that, I'm going to just go ahead and do the needful here. Total GSC. Now, this is the total scores for a person. So this has to be continuous. And these are some other questions the student has collected. The scale was administered for teachers. So this is number of teaching subjects that is continuous. Teaching experience, continuous. Number of grades they teach, that is also continuous. And she has done Mahalanobis distance as well. So we don't need those. Now, this is the basic data set. Now, although sometimes students feel a little bit overwhelmed about fact analysis, I'll show you how exactly it can easily be done through Jamovi. So what you have to do is this. You can see here there are some tabs. These for data exploration, t-test, ANOVA, regression, frequencies, and fact analysis. If you are a psychology student, I think this software offers you all the necessary analysis that you need to run. And if there's anything else that you need to run, or if you need to get more detailed output on fact analysis, I have written a book about how to do that in RStudio. So RStudio, you have a greater capacity to get more output as well, and there's so much of customizability as well. Okay, but let's discuss here how exactly we are going to do this. So click on factor. And I'm going to first select fact analysis here. Now, there are two types of fact analysis. One is exploratory fact analysis and the other one is confirmatory fact analysis. Now, exploratory fact analysis is usually done to explore the internal factor structure of a scale. Now, I have a 10-item scale. This scale was originally in English. That is the unidimensional scale. Now, we culturally adapted, and during that process, we translated it to Sinhala language. Now, although I know it needs to be unidimensional, I need to make sure that it still will be the same in our country as well. So, because there are cultural differences, so there could be other factors here reflected in our data as well. So, I'm not sure about that. If you are very sure about that, then you can go with the confirmatory fact analysis and confirm that this unidimensional structure is available in your data. That is also one way to go ahead. But here I'm going to just go with exploratory factor analysis. Now, exploratory factor analysis and principal component analysis are also two different things. Principal component analysis, based on literature that I have read, what it says is it's a way to reduce a set of items into dimensions. Now I have 10 items. I'm going to figure out how many dimensions, so how many factors I have in this. So you can either go with exploratory factor analysis, you can either, if not, you can go with principal component analysis. I generally tend to go with principal component analysis because my intention is to see how many dimensions are there. Unidimensional means one dimension, and I'm going to just see whether that's the case here. So I'm going to click on that. Now, when I just click on this, you would notice on the left side, I have my, what do you call the stuff that I need to click in order to get the output. And on the right side, you would see the output. So here we have some blank output. The first thing that you need to do is you need to select all your questions. Now I have 10 items. So question number 1 to number 10, I'm going to select these guys and I'm going to send them to the variable side. Okay, now let's see. Now this is component loadings. Now this is the first output it gives. But before I go through this output, I need to make sure that I have made the assumptions of factorability right. Assumptions of factorability, there are two. One is the KMO index and the other one is Bartlett's test of sphericity. I'm going to first get the KMO index. This is to see whether our sample size is enough to go for a factor analysis to see whether generalized self-height scale is unidimensional or not. Now, this is the KMO index for each item, but if you go with the overall KMO index is 0.876. Now, this has to be more than 0.6. Sample adequacy based on KMO index, the resulting value has to go beyond 0.6 to indicate that it is adequate sample size. So this is okay. We have met the first assumption of factorability. And then I'm going to go ahead and click on this Bartlett's test of sphericity as well. Now, Bartlett's test of sphericity is also significant, as you see here. So as a result, I have met all the requirements to go ahead with factor analysis. Now, usually at this stage, it would be better to compare your correlation matrix as well for the 10 items. But that has to be done through reliability analysis. We'll get to that a little bit later. But just let's see, before we do check for reliability, whether we have the required factor structure. Okay, now here there's another option called rotation. Now, some of you might not know what a rotation technique is. Let's say you have a unidimensional solution, one factor solution. In that case, sometimes, we don't need to use any rotations. If the loadings fall under one factor without any issue, then we have nothing to worry. But think about the scenario where you have a couple of so factors in your scale, and then those scale, the factors are, the items get loaded under each of the factors. Now, sometimes the initial factor analysis solution or the PCA solution might not represent what we are expecting. So at that time, what we do is we engage in some rotations. Now, there are different rotation techniques. The technique is dependent upon your understanding about how the factors are going to relate with each other. In some scales, the factors do correlate with each other. If that's the case, then we call them, whatever the analysis, whatever the rotation that you have to use, then it has to be oblique rotation. So there are some oblique types of rotation. For example, oblimin is a oblique type of rotation. And sometimes in certain scales, the factors do not correlate with each other. So we call them, in that kind of situations, we use orthogonal rotation techniques like Varimax. Now, uh, this is if I remember it correctly. I think, yeah, Varimax is an orthogonal rotation technique. But here I don't need any rotation, so I'm going to just click none. Why? Because uh, I'm not interested in going for a rotation first. If my loadings do not load under a single component, then I will actually go for a rotation technique. If not, I can always get a solution without any rotation. Now let's go through this fact analysis here. Here we have component one. Seems like I have only one significant component and all my items fall under this. Now question number one in general self-efficacy has a loading of 0.662. So this pretty much indicates how much of a relationship it has with the component. Now here there is an option. You can hide all the loadings below 0.3, which means if you have any loading under 0.3, let's say 0.29, then that will be removed from here. I'm going to actually increase this to 0.5 because I need better loadings. Let's see whether my items are still going to be here. Yes, see, even if I tell Jamovi to hide my loadings below 0.5, still these items are well represented under this main component. Why? Because all my loadings are more than 0.5. So this is a pretty good solution. And here we can actually, if you remember the Kaiser's criterion, it says, if I need to retain a factor, the factor has to have an eigenvalue more than one. So I am going to here retain the factors that are eigenvalue greater than 1. So I'm going to select that as well and keep 1 as it is. If you need a fixed number of factors, let's say you are looking for 2 factors, then you can actually click on this and put 2 instead of 1. Now, in our case, theoretically, generalized self-efficacy, it has been done in more than 30 countries. It has been replicated in more than 30 countries. It always is, for the most part, a unidimensional solution. So I'm going to just keep it like this. And then I'm going to get a component summary as well. Now see, this is my component summary. We have one significant component, okay? And this significant component can actually explain. So I think the eigenvalue is 4.32, and then it actually can explain 43.2% of the total variance. So uh, it accounts for 43.2% of the observed variance of these items. So 43.2% of variance is actually pretty good. And then we don't need to find component correlations because I have only one component, but if you have multiple components, you can actually go for component correlations as well. But this is going to be just, it doesn't yield anything because I have only one component. And then I'm going to get a scree plot. Scree plot is us visually observing our fact analysis. Now, my 10 items have only one significant factor, which means significant factor or significant component means that's the latent variable that I'm interested in finding. I need to make sure my 10 items measure only general self-efficacy because this is a generalized self-efficacy scale. So if all the 10 items measure the same, then I should have only one factor here or one component here. And if you notice, my first component is 4 point something eigenvalue and everything else falls under 1. But if you notice very closely here, I have a second component that is very close to 1 as well. So if you run this on SPSS, it will give you a bit of a bigger output for fact analysis, so principal component analysis, where it will show you, other components as well. Now, there's something that you have to consider. If you need to retain more than one factor or more than one component, if you have a second component, the second component should have at least 3 loadings under its component. So if it is 0.662 here, but under component 2, if it says 0.7, then you are going to consider that 0.7 instead of the 0.662. What it means is the question number 1 GSC actually falls under the component 2 instead of component 1. However, now in this, I think one of the items actually do fall under a different component. But the thing is that component has only one item. Now, in a research paper that I read, written by Professor Ralph Schlosser, the original author of General Self-Efficacy Scale, he says you need to have at least 3 items for a factor, and that factor should explain at least 5% of the total variance. Now, in this case, the factor or the component has failed to retain 3 or more items under its the component. So because of that, I'm going to confirm that this is a unidimensional solution because this is our significant factor. So all the 10 items measure self-efficacy. Now, this is exactly how you would do basic fact analysis in the simplest form. Now, you are very lucky if you get something like this where it directly falls under one component. So then your life is easy. But if you don't have your the items fall under the same component, then you would have to use a rotation. And after that rotation, you have to further evaluate and see how exactly the items get loaded under the different components. And based on that, you have to come to a conclusion. Now, this is one of the reasons why we actually do content validity with experts to see whether our translations are okay, whether the conceptual meanings are retained, whether the words are appropriately worded, because every mistake that we do in the translation process or in the development process would be reflected in this. Because if our items do not fall under components properly, it just unnecessarily burdens ourselves, and also it makes our life really miserable. So now what I'm going to do is I'm going to do a reliability analysis. Once again, the output will appear on the right. I'm going to just select these guys, all the 10 items. You select them and put to the other side. Now it first generates Cronbach's alpha. Cronbach's alpha is 0.851, which is pretty good. And I'm going to go for Cronbach's alpha if an item is dropped. Now, the overall scale has a Cronbach alpha of 0.851. Now, I am going to see if one of the items is taken out of the 10 item scale, whether the overall alpha is going to go up beyond 0.851. If by any chance, when you remove an item, if the reliability is going to go up than 0.851, what it means is that item probably has some issue. And this will be reflected in a correlation matrix as well. Now, here, luckily, I don't have any of those issues because when you run your factor analysis, sometimes there could be certain items that do not get loaded properly, problematic items with, very poor loading scores. Those items would have some issues when you even check for reliability as well. Now here in this one, we absolutely have no issues because nothing seems to go beyond 0.851. So pretty good. Even if an item is removed, the Cronbach alpha is not going to go beyond the overall for all the 10 items. And I'm going to get item and the rest correlation. Some say this is item total correlation. So what we try to do is we try to correlate the scores, the average score of each item with the total of the rest of the 9 items. So for example, GSES, this item 1 has a correlation of 0.557 with the rest of the scores of the other items. And if you notice, all the correlations are really good. If you have poor correlations here for some items, what it means is those items would have some issues, which means those items might not be very reliable. These items might not be very good at detecting the latent variable of the person. Now, this can be also studied, the items can also be studied through item response theory as well, but that's a lesson for a different day, and I'm not going to do that today in this one. So, and here there's another very good option here. Now, in SPSS, you can get a correlation matrix, but Jamovi actually has a correlation heat map. I really like this. Why? Because you can immediately notice the problems. Now, if you notice here, the red color indicates negative correlations. Now, this is a unidimensional scale. There's no way that I'm going to get negative correlations. If there's a negative correlation, that means one or two items have some big issue. Probably that is related to a translational issue as well. If that's the case, one should first ask how exact it came through the content validity without any issue from an expert panel. Now, if you have any negative ones, it will be in red. I don't have any red color problems here. At the same time, bigger correlations, highly significant ones like 0.8 and above, that would be, multicollinearity. Seems like I don't have any multicollinearity issues as well, because then this would look uh, dark green. Now, I don't have that. So it seems like I don't have any multicollinearity issues, singularity issues, no negative correlations, no poor correlations. So I think it's a pretty good, scale. There are some 0.2 values, that is GSCS number 2 with GSCS number 3. And if you notice, GSCS number 2 tends to have poor correlations throughout, and GSCS number 3 tend to have poor correlations as well. See 0.1. GSCS number 6 has 0.2 here once again. Now, some items, now let's check this. Number 6, number 2, and number 3. Number 2, the item total correlation is 0.49, 3 is 0.4, 6 is 0.4. If you notice, those three items have item total correlations that are significantly lesser than rest of the items. See, these are 0.76, so on and so on. So that is exactly how you would notice. Now, if you do this in R, it will give you more reliability statistics as well. It will give you felt and Duha check estimates, signal to noise ratio, and then it will give output again through Gutman lambda 6 as well. So depending on the software, you can go for different types of findings and analysis. But this is just a very easy way of getting stuff done. I mean, uh, it it doesn't even waste any time as well. You just have the data, and then it's a matter of clicking these buttons and then doing your interpretation. Now, if you have all of this, you can actually go for confirmatory fact analysis as well. Now I'm going to go for confirmatory fact analysis. Now, here I am going to once again select all my items, and I'm going to put them all in this factor. This is my factor one. I'm going to name my factor as GSES. Actually, you know what, I'm going to say SGSCS, because that is Sinhala Generalized Self-Efficacy Scale. And I'm going to just go for my model fit. I need to see, now we know our scale is unidimensional. And now what we are trying to do is, okay, look, if we have a unidimensional scale, which means we have one latent variable, 10 items, that is our model. I am going to see whether my model is actually significant or not. Now, here's how I'm going to do this. Now, model fit has to be measured through fit measures, CFI, TLI, and RUMC. These are the most commonly used fit measures. You can use AIC, BIC as well. Now, in item response theory, for certain models, for the model testing, we use AIC and BIC. But here, we are going to use the exact fit, goodness of fit index, and then CFI, TLI, and Ramsey. So CFI value is 0.932, TLI is uh, point 913, and Ramsey is 0.07. Now there are some cutoff points. You have to evaluate CIF, TLI, and Ramsey values based on this cutoff point. So I just got this from I just searched this in Google, got the cutoff points. Okay, let me again open it up. CFI, give me a second. CFI, TLI, okay, cutoff scores. Okay, so CFI, comparative fit index. It's a revised form of NFI, not very sensitive to sample size. Okay. CFI has to be larger than 0.90. Let's check that. Okay, my CFI is 0.932. That's all right. And then I'm going to check TLI. TLI is the Tucker-Lewis index. Once again, an NFI of 0.95 indicates the model of interest improves the fit by 95% relative to the null model. Now, a value closer to 0.95 is better here. Mine is 0.913, so I'm going to consider it as okay. And then I'm going to check Ramsey. Root mean square error of approximation. Values closer to 0 is generally considered as good. So Ramsey has to be less than 0.08. Let's check. Mine is 0.07. It has to be less than 0.08. So this is also okay. So I think this is good. So if this is significant here, the test for exact fit, so that's okay. And what you need to do is when you interpret the model in CFA, you can use these values to justify the quality of your model. If CFI, TLI, and Ramsey, and if those are a good fit, you can pretty much say, your model is a good fit. But then again, if you can compare all of this, because depending on the field that you are in, if you're a statistician, you might have a higher chance of, interpreting these values. But just for what we do here, I think this is more than enough for us to know that our model is significant. So CFI, TLI, and Ramsey values say that's okay. And then you can go for additional output. And then from here, you can actually obtain the path diagram as well. So this is the path diagram. We have 10 items. This is our latent variable, generalized self-efficacy. And all the 10 items measure general self-efficacy. And this model fits very well, which is what we interpreted using CFI, TLI, and Ramsey. So that's how you run a confirmatory fact analysis. Now, one could ask, should I run a confirmatory fact analysis or a exploratory fact analysis, principal component analysis? Well, you can always start with principal component analysis, and then you can do a reliability analysis. And if you want, you can go for a confirmatory fact analysis in a secondary study where you get more data, and then you actually go ahead and confirm that your model is actually right. Or if you have strong theoretical support that this is exactly how the model is going to work, then why not you run a confirmatory fact analysis and confirm your model? Now, all of this is subjected to how you would justify everything in your research. So it's very important that you talk to your supervisor or talk to your class teacher or the lecturer or the professor and ask what they think about all of this as well, depending on the field that the person is in and depending on their experience and depending on the stuff that they have read, their answers will vary to some degree. Okay. So this is exactly how we would run fact analysis. So now we have learned how to do exploratory fact analysis, confirmatory fact analysis, and also reliability analysis through Jamovi. I hope this will clear most of the doubts if you have about this. So I would also encourage you to read our study protocol for household water insecurity scale, because there I have explained this method very thoroughly. So you can first read that and then watch this video again. So there you would have some degree of comparison. what the theory says and how exactly the practical things would uh, support you to understand more about the theory you have learned. Okay, so that is exactly what we learned today. And in future, I will make another video about item response theory as well, so that you can also learn a little bit about how that also works. But for today, this is it from my end. And have a very good day. And I will see you guys again. Thank you very much.